artificial intelligence, deep learning, and he is willing to share his insights on mastering essential skills, exploring various career paths, and enhancing your problem solving and thinking abilities in computer vision engineering. Before we begin, a few things to keep in mind. Please keep your microphones muted during the presentation to avoid any background noises. Feel free to post your questions in the chat box. We'll have a question answer session towards the end where Mr. Goel will address them. And this session is being recorded and will be available for later viewing. Now, without making any delay, let's welcome Mr. Parash Goel. Parash sir, over to you.
Hello, everyone. Thanks a lot, Afreen, for that introduction.
Thank you, sir.
Yeah, really glad to help the students get on board with computer vision and start their journey on this path that's actually challenging, a bit challenging for everyone. But I hope after this session, some of you guys will actually get started with computer vision and you'll find it a bit more easier, or you'll find actually the steps to take should be clear after this session, that how to proceed with that. So without further ado, let me share my screen so that you guys can see my presentation, and then I can start. Let me know if everyone is able to see the screen.
Yes, sir, your screen is visible.
Great. Okay. All right. So today I'll be presenting a roadmap to become a successful computer vision engineer. I understand that you guys have done a course in data science and want to understand the path from this point to become a successful computer vision engineer. So I'll lay out a few guidelines or few steps that you can take further in that direction to help you achieve that goal. The agenda for this discussion today would be that I'll be first touching upon the importance of data science and computer vision, and then some basic intro to data science. I know you would already be aware of data science. You have a background in that, but still I'll just give a quick overview of data science, and then I'll proceed into the details of computer vision with its applications and then skills that are needed for computer vision. Along with that, I'll be giving some learning pathways that you can take to navigate this path successfully. We'll also be going over some hands-on coding to really get you started and get your hands dirty and understanding how people use computer vision for manipulating with images and how people use PyTorch to actually train their neural network models. Towards the end, we'll have a time for Q&A session as well, where you can clarify whatever doubts you'll have. So the importance of data science and computer vision. Both are equally important field and both enjoy equal privilege in the industry and academia. Data science, as you would already know, is actually based on data-driven decision making. So you would have some data based on which you would want to give some insights to your customers or to the clients to understand their business better. For example, there might be a client that would be requesting you to gather some insights about their market share and understand which potential user market they should target. Should they target youth market, or should they target teenager market, and so on? So all that insights you'll have to gather. You will first have to collect the data for it, and then you'll have to gather some understanding about that data, possibly through visualization, through looking at some charts, some graphs, and then possibly you will have some more understanding about that market, and you will be able to give your client a particular strategy which they can use to optimize and manage their operations and risks. So in a nutshell, that's what data science is. So, and coming to computer vision is actually a bit different from that, in the sense here your input data is actually image or video or some other form of vision-based data or visual data. Now, this data, visual data, could be anything, like I just said. It could be images, it could be videos, or it could be some other, data coming from time of flight sensor, data coming from IR, which actually tells you the information about the current thing that sensor is seeing, or the current world or the field of view that particular sensor is having. For example, if it's a camera, then it would be seeing some visual data such as images and all. If it's a thermal camera, that's a IR or something else, then it could be seeing a thermal view of the world around it. So all that is visual data, and we want to develop algorithms to manipulate that data and gather and do meaningful stuff with that. So the core idea is to enable the machines to see and interpret their surroundings like we humans do. For us, the humans, our cameras are our eyes, and our brain already has complex algorithms developed, which has actually evolved over time to use the information coming from the eyes to understand the world around us. Now we want to do the same things for computers and these machines. So the camera is a camera, as you would know, and that would give you either images or videos. Videos are again collection of images spread across time, and then you would manipulate that to gather meaningful insights about the surroundings or about the scene that the camera is actually seeing. It has various applications in healthcare, in transportation, security, even in manufacturing, robotics, whatever you could think of. There are a lot of applications for computer vision. So data science, on a high level, this slide explains what data science is. Let's quickly go over this. I won't give much details about this because that's not the agenda for today. So data science, I would like to say that it's a multidisciplinary approach where you would want to combine domain expertise and mathematics knowledge and your computer science. And you will want to use all the three of those to extract meaningful insights about the data. So in the Venn diagram that we can see here, the intersection of the three domains actually represents where a data scientist would be working on. So all the three are critical for a successful data science career. Now, the key skills that are needed in data science are statistical analysis, that you would want to analyze your data meaningfully and statistically. And you would want to have machine learning skills. That's your tool through which you would be able to build some algorithms to extract meaningful insights about the data. And then you would want to do data visualization. For that, there are different libraries such as Matplotlib, Seaborn, etc., from which you can plot meaningful and interactive plots to understand more about the data. Now, for all this, you need some programming languages such as Python, R, and SQL is needed for data manipulation. And then you'll also have to do data cleaning because in real world, the data is never clean. And there are a lot of noise in it, or there are a lot of unwanted things which we want to eliminate and which might, if not eliminated, they might hamper our visualization or our insights from the data. Now, like I already told, different tools that are needed around these skills are Python for data manipulation and analysis. R is again needed for same thing, the analysis and visualization. SQL is needed for databases and extracting the data. And then Tableau or Power BI, they are powerful tools just to create good visualizations, which you can share with different people and gather more insights about the data. This is about data science. For computer vision, I'll go a bit more into the detail and different applications of computer vision because this might be new for some of you. So for computer vision, I would like, as I've already told you, it's a field of AI that helps computers to interpret and understand the visual world around them. So there are different applications. For example, facial recognition. I'll show you some examples of a few of these applications. So facial recognition, where you would want to detect if a person is having a same face as already registered face. For example, for attendance in an office, say you have 10 employees and all 10 of those are registered in your system. So when on a new day, whenever on a working day, when a particular employee enters the building, he could just scan his face to get the attendance mark. That's one way for facial recognition. And then object detection, autonomous vehicles, medical image analysis. And medical image analysis is one field which is still being transformed by AI, I would say, because it requires very precise and accurate systems, because you would not want to have slight error, because uh, uh, the consequences of having a failure or a error and then that leading to a person's fatality are higher, and we would want to avoid that. So the margin of error is very low in medical images, and that's why people are taking cautious path in adopting AI and replacing manual or humans with AI in medical field. But as we speak, it's still being transitioned and transformed by computer vision. The different techniques that form the basis for computer vision are image processing, where, for example, whenever a camera captures an image, it's basically a signal for the camera. Now you would want to apply different techniques to those signals to remove the noise and get a good quality picture that you can view as a human, because the signal is just bits, zeros and ones. Now you would want to capture some meaningful insights and draw a good image that we as humans can view and perceive. So the techniques and algorithms that are done on that signal that's acquired by the camera, they come in image processing. Then pattern recognition and machine learning are just the standard things that people use for applying on images. And then deep learning algorithms. In the last 10 years or so, deep learning has accelerated the field of computer vision quite a bit. And that actually started with a good paper that was AlexNet, if you have heard of. Uh, it came in around 2012, I believe. And after that, people actually started using computer vision with deep learning, or they invented newer and newer algorithms. And today, right now, the state is that every year there are state-of-the-art algorithms coming for the same tasks listed above, such as object detection or facial recognition. And the field is expanding very rapidly, and it's really hard to catch up with all the advancements that are happening at such a quick pace. Uh, the benefits of computer vision are that it enhances automation and it improves the accuracy because we don't have to rely on humans on a lot of tasks now. And then it enables newer capabilities in robotics or surveillance and healthcare. However, there are a few challenges as well. For example, the quality of the data, because the data that we use to train our models, uh, it should be very good. Otherwise, our models will be as good as the data. That's a common saying. Because if you don't have good data and you are using those to train your models, then your models will also not perform well. So the data quality is a critical factor whenever you are training a deep learning algorithm uh, for any task, irrespective of it's for computer vision or NLP or any other thing. Then interpretability, because these deep learning algorithms, they are like a black box. So if it's not working, then it's really hard to figure out which part of the pipeline is causing the problem or where the issue is. So the interpretability is a important concern, and people are finding ways to debug and fix these uh, deep learning models through different and newer techniques. Then there are ethical concerns as well, because a lot of the models that are trained, they are trained on publicly available data. For example, data from YouTube or data from images that you would post on your social media, such as Facebook, Instagram, etc. Um, but people would not have given approval to the companies that are building these models to use their data. So, in a sense it's not ethically correct to use those data. But then the responsible companies out there, they are actually taking good concern. They're actually taking good amount of care to ensure that the data that they are using, it's appropriate and it can be used correctly. And the last challenge I would mention is that ensuring robustness in real world application. Because say if you have a good model that you have built for self-driving car, and it works really well 99% of the time, but that 1% could also be fatal for the driver sitting in that car or the passenger sitting in that car. So it's really important that the models that we build are really robust in the real world, and that's critical for any successful computer vision model. At this point, I would just pause for a minute and quickly we'll see if there are any questions. Otherwise, we can proceed. So if you guys have any questions, please feel free to ask. No? All right. I'll move from here. Yeah.
Sir, I have one question.
Yes,
Sir, as you mentioned about the data set, so what type of data set should be used for computer vision?
that really depends on your task that you're trying to achieve. Um, if it's something related to face, such as, like I mentioned, the example of facial recognition, then you would want to use a data set of faces. Uh, and there will be different pre-processing techniques applied on top of those data sets as well. Because you would gather some data from YouTube, say, or from any online available source, such as Flickr or some other website which has a lot of such images. But those images, the face might be a bit smaller or it might be too large. So you would want to do all those pre-processing to ensure that you filter out irrelevant content and just use the faces that you want to use. Uh, but the data set that you would really use depends on the problem that you want to achieve, that you want to solve. For autonomous vehicles, such as for lane detection, you would want to use images of roads and with lane markings on them. So there are different data sets for different problems.
Okay, sir.
Hi.
So Manohar has some question.
Yeah, please.
Yes, Manohar.
Yeah, sir, am I audible?
Yes, you are.
Yes, sir. I would like to just ask that how does computers like process the image? Is it like pixel wise or like entire image is considered into some matrix and all?
Okay. Uh, I'll go over that a bit later in my presentation, but to quickly answer your question, image is constructed as a 3D array of height, width, and three as the depth dimension. The depth dimension indicates the RGB channels, and then you could consider this as a 3D matrix, and then the algorithms process the 3D matrix.
Okay, sir.
Can I ask a question?
Yeah, please.
Yeah, hi. I actually work on OpenCV. I don't work actually. I'm work learning via OpenCV. So, what do you suggest? Is it? I mean, I use C++. So, which one is efficient, Python or Open C++?
For quick prototyping, POCs, demos, Python is more, I think, easier to use. But
Okay.
if you would want to deploy it in a solution where
Uh-huh.
the latency is important or real-time performance is important, then go for C++ because that will be faster in real time.
Yeah. Yeah. Right.
Yeah,
Right. Okay. All right. Thanks.
yeah. All right. Moving on. Uh, a few applications just to build your interest in computer vision. It's important to give a few applications that will be through which you could know what exactly is happening on these images and what are the different things people are building using the computer vision algorithms. So a few of these solutions are actually released by Nvidia, and these are actually released by my team. I work for Maxine team in Nvidia, and we have released a few solutions out there for video conferencing. So Maxine is a NVIDIA SDK that specifically targets video conferencing scenario. And I'll be going over a few examples of what we have released out there for the public. So first example is Maxine Eye Contact. Uh, what you notice in this picture is that on the left side, the lady is looking towards sideways. Her eyes or the gaze is not positioned towards the camera. Whereas when the eye contact feature is applied, she is directly looking at the camera. Now, this particular use case is targeting the video conferencing users because what happens is for a interactive experience and for an engaging experience, it's important that the person is looking directly into the camera so that the uh, the listeners can actually have a connect with the speaker. And this really solves that problem. And you can see that the output looks as good as original. You can't tell through the output that the this is not the original image, but it's a modified version. So that's one example. The next one is these are different solutions of the Maxine SDK. On the top left, you would notice a person and a box drawn around his face. So that's actually a face detection and tracking algorithm. In each frame of the video sequence, we will detect where the person's face is and we'll draw a bounding box around that. And you could use that information of the person's face for any other downstream task. Uh, for example, you could add filters such as make the person wear glasses, or uh, have the person more beard or something else, whatever you would want to do with this information of the face bounding box. Um, so this has direct applications in augmented reality. Then there are similar solutions, but instead of drawing a face, we detect landmarks on the face, such as you would notice in the top right and the bottom left image that we have some dots on the face that are actually the different landmarks that we are detecting on the face. For example, you could notice the dots on the eyes, on the nose, around the lips. They, these two are different versions of the same solution. The top right one, it just detects 68 landmarks around the face. The bottom left one, it detects 126 landmarks on the face. So it's the output here is a bit more dense and it has a bit more information as compared to the 68 version. And then the last one is for face mesh, 3D mesh and tracking. So instead of just detecting the points on the face, we can actually detect a complete mesh. And you could use that to animate a virtual character through Unity or Blender or Unreal Engine. And that character could mimic the motion of this person, because say if the person is moving his head towards left or right, then the face mesh will also capture that information. And when you feed that face mesh to a character, uh, to a virtual character, then that could also be animated accordingly, in the sense that that could also move from left to right. So these are different solutions that Maxine SDK provides for manipulating or for extracting information from the faces.
Uh,
Yeah.
Yeah, excuse me, sir. I have a question. Let's say the CV computer vision is have an application in the agriculture and healthcare sector. As well, what benefit or it could have on the school system? How it could be helpful for a student coming to school or school ecosystem. So that's what I want to ask.
Okay. What I could think of, it firstly, it actually depends on your imagination and your creativity. The possibilities are endless. So you could always apply computer vision to a specific scenario which no one would have thought of, and that's actually related to schooling and education. But a quick example could be to make the learning a bit more interactive, in the sense that you can show the students some videos, and then those those videos could be the students could manipulate those videos. For example, say if there is a video showing Apple in a scene, then you could ask the students, if they are KG students, like kindergarten students, where is the apple? And when the person or when the student clicks on that apple, that kind of segments out or pops out from the video to show that it's actually a correct answer that they gave. Now, that segmentation part where you are uh, detecting the object in the video, that's actually done through computer vision. So uh, you could apply computer vision to any task as long as you have enough creativity and imagination to. Firstly, you'll have to identify the problem, and for that, you'll need to study the ecosystem a bit. What are the existing solutions out there for education and schooling related stuff? And then once you know that, you would know where is the current gap, and you could try to fill that gap using your creativity and computer vision intertwined together.
Okay, sir. Thank you.
Sorry to interrupt, sir. Am I audible?
Yes, you are.
I'm Devshu from the Student Placement Council. I would like everyone to please turn on your camera and let's make the session as interactive as possible. And hope you will enjoy this session and this information will help. Thank you, sir.
Yeah,
You
thank
can
you,
continue.
Devesh. I actually wanted to request that, because it will be good if people can turn on the camera. It will be more interactive that way.
Yes, it will become a
Yes, sir.
two-way
So
communication that.
Yeah.
please kindly, those who can, switch on your cameras if possible.
All right. Uh, let's move on. So this is another application. You see a person, and we are able to detect the pose of the person, such as the angle at which the arm is bent, or where the elbow, the wrist, the fingers, or the neck, and at other joints are there on the body. And through this information, we are able to reconstruct a skeleton. Now, what could be a possible application for this? It depends on the use case, but one application could again be to drive a virtual character in a video game or in a AR environment, or even a virtual reality environment. You could feed this pose information into the game, and the character then animates according to the pose of the person in the input image or the input video. So it would feel like the virtual character is actually mimicking what the person is doing in the video. And just to mention, this was a product that I actually worked on, and I was able to like take it to a commercial release. So we also support adding just the upper body in frame. For example, right now I'm talking to you. You are only able to see my upper body. Even for such scenarios, we were able to detect the skeleton or the 3D body pose, and we were able to pass that information to other applications on top to drive the virtual characters. Now you notice that it is 3D body pose tracking and not just 2D, because images are usually 2D, where you just have the X and Y information. You don't have the depth information. But we were able to build good computer vision algorithms to actually extract 3D information from just 2D images. So in a way, we were able to get an extra degree of freedom by just using 2D or two degrees of freedom. And apart from all the applications that I have given you until now, they were targeted for video conferencing, and that's because our SDK, that's Maxine SDK, it works for video conferencing users. But I'll also want to present some applications after that, or apart from video conferencing. A few applications for transportation are as follows. So one is pedestrian detection. You can see on the left side that the algorithm is able to detect different people in the image and classify them as pedestrians. This is important, for example, for a self-driving car, where you would not want to hit a person walking on the road, right? That will be catastrophic. So we want to avoid that, and for that, such algorithms should be in place. And a commercial solution would take the images from the cameras mounted on the car, process the information on the car itself, and then give out the output to the self-driving system in the car that there is a pedestrian in front and you should slow down or you should brake. And then there is lane detection also that's applied in self-driving technology. For example, you have put the car on cruise mode. Now you just want to have it maintain a speed and just follow a particular lane. But at each frame, it needs to detect where exactly the lane is, because the road might be curving or it could be turning. So you would want to detect where the exact lane is, and you would want to maintain that. And that's also critical for transportation or self-driving. In healthcare, as I mentioned earlier, it's still early stages for computer vision in healthcare, where it's still transforming the industry. One example is in X-rays or MRIs or CT analysis, where so if you would have gone for a diagnosis for an X-ray or anything, you would have noticed that when you get the X-ray printout, the physician, they look at it manually, but humans are bound to miss minute details or subtle patterns. Whereas if we can build intelligent systems using computer vision and deep learning, then they can pick up patterns in the images which are too subtle for the human eyes. For example, in the left X-ray, we can notice that the algorithm is able to detect that the person is having an enlarged heart in the red region. And through this, they are able to inform the doctor that this might be some problem that the person is having, and we need to do a proper diagnosis for this further. Whereas a doctor might have missed this information otherwise. Similarly, on the right side, we can notice that it's also helping detect the skin cancer and melanoma. For that, so cancer is a condition where you would have some moles on your body, and not all the moles would be indicative of a skin cancer, but some of them might be. For example, in this image, there was one mole that's classified that has a high risk value, and then the system is able to classify that, okay, this particular mole has a high risk value, and it tells the doctor that you should do some further tests and identify if the person really has a skin cancer or not. And through this, it would be helpful for the patient because they would get diagnosed early in early stages, and then the skin cancer can be treated. So this 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 is the way it's helping save lives in healthcare and transforming the industry. Even in manufacturing, we see a few applications. For example, on the left side, consider a scenario where we have a manufacturing industry of making medicines. Now, in each pack of the tablets or the capsules, we should have 10 capsules ideally. But for example, in this image, one of the capsules was missing. And the algorithm that's probably deployed on the assembly line, it's able to detect that this particular pack, it's having a missing pill, and then you should discard this particular pack. So it will pass that information further down the assembly line, which will accordingly automate the removal of this particular package so that it does not get packaged into the shipment to be sent to the customers. So through this, it's able to automate the quality control and then minimize safety risks and also increase the efficiency. Then consider a scenario of a warehouse, for example, say Amazon warehouse, where you would want to sort the different boxes according to their locations and according to their destinations. For that, we could have a OCR system. OCR is just optical character recognition. It identifies the different text in the input images. And that could help us to detect the barcodes. And through those barcodes, we could possibly identify where the destination of the package is. And we could sort the boxes accordingly. So again, it's reducing the human intervention. It's also increasing the production efficiency because these systems, they can work round the clock for 24 hours and can be helpful and are not bound for human fatigue, or not bound for human errors as well. Sorry. All right. Now we'll be going over the skill set for computer vision. Before that, if there are any other questions, I can take those. No questions?
Sir, how would we
Yeah.
extract 3D, the depth information from an image, which is basically a 2D picture?
Yeah.
So,
There are different ways for doing that. Like for the example that I gave here, what we were doing was we were calculating the different limb lengths of the person's arms, say for example. So the length from elbow to the wrist in 2D itself. You would at least know the 2D positions of both, right?
yeah,
And you would also know an average person's human arm's length,
yeah, definitely.
right? Now you can correlate that uh, to have a scale value that tells you
Okay.
that how much of a scale you need to apply to actually get that value in 3D. And using that and some other different techniques, we were able to identify the depth information.
So, but then how would you differentiate the environment from that specific object?
Environment as in
The background wall, how would you differentiate it from the?
that's taken care of by the deep learning algorithms. You need to build such algorithms that are able to distinguish between the foreground and the background. For example, one common pre-processing technique that we do even before applying a computer vision algorithm is to extract a bounding box around the person. So instead of feeding this complete image to the algorithm, because it has a lot of background information as well, right? What you
Yeah.
would do is you would just identify where the person is in the image and create a bounding box around it. So for example, a rectangle bounding box around this person and crop out that region from the image and then feed that to your algorithm. So you are already reducing the lot of background information which was not necessary for the algorithm.
Okay. Thank you, sir.
Yeah. Yes, Manohar.
Sir, I would like to ask that if the model contains the information about the average human's hand size, then if the image contains some like enlarged version of the hand, would it still recognize the hand?
If it's just containing the hand and not the complete body of the person, then it would not recognize it. Because we need at least the upper body of the person to be in the frame to be able to detect the skeleton of the person.
Okay, sir.
Yes. Are there
Excuse
any
me,
other
sir, I
questions?
have a question.
Yeah.
Sir, to remain up to date with all the upcoming technologies in the CV field, can you suggest any blogs or any podcasts or any newsletters which we can keep ourselves updated with?
Yeah, sure. I was coming to that. We'll get to the slide in a few moments.
Okay.
Sir, I have a question.
Yeah.
Sir, what metrics do we use for comparing the CV algorithms? Sir? Like, which is good and which is bad? Like, how we
There are different
compare?
metrics actually for different tasks that you would like to do. For example, let's consider, let me see. Let's consider this 3D body pose solution. Here, your outputs, if you see the outputs, what are those? Those would be the XYZ location of the different key points on the body, right? Now, those are just numbers, or you, in a sense, you are building a regression model to predict the X, Y, and Z location. So for this application, a mean square error would work.
Okay.
But for the next application, say this one where you are actually doing a segmentation, so here you are actually telling which pixel belongs to a lung or which pixel belongs to what. So you are classifying different pixels into different categories. Here, a mean square error won't work, and it's actually a classification problem. Here, you would want to do something called mean IOU, intersection over union. So
Yes.
there are different metrics or suitable metrics according to the applications that you are targeting. There is nothing such as one size fits all or one metric fits all the application.
Okay. Sir.
Yeah.
Thank you. Sir.
Okay.
Sir, good evening. Sorry to interrupt you. Mano, this
Yeah.
side, sir.
Yes.
Just very little curious, sir. I just thought of for example, so if you take a very big hospital, for example, AIIMS, New Delhi or PGI Chandigarh, sir, the cancer cases are on the rise due to numerous factors. For example, so if you have to find the specific reason why is any cause for the cancer increase, sir, we have this MRI scan, sir, that are generated on a very large scale, sir. And along with the MRI scan, with the patient case history, whether he's a smoker, drinker, or he's exposed to pesticides or exposed to other chemicals or something, whole database is there along with one MRI scan of the patient, sir. Suppose we have to, if we take a big hospital like PGI Chandigarh, sir, there on an average, sir, there will be around, I can say, up to 10,000 or more than CT scans will be done on the per day, sir, basis, sir. If you have to enumerate all this on very large scale, for example, if you have to analyze 10 crores MRIs along with the 10 crores, along with the database that will also go around close to 10 crores, sir. How can, sir, we utilize that so that we can have a insight that in this particular region or in this particular hospital, the major cause is going to be this, and we are lacking in this. This can be the major cause for increase in the cancer cases in the specific region, sir.
Okay. So firstly, it's good that you have such a large data set that you are mentioning. But there could be some caveat in that, in the sense the data set that you would have, it won't be clean, because at the end, there would be manual annotation involved in it. So when people are writing down the case histories, it's actually humans who are doing that. So you need to figure out the margin of error there too. And once you figure that out, you will have to build some kind of algorithms that take the MRIs and analyze those. So a computer vision algorithm for that. And then another piece of algorithm that takes the case history of the person. Possibly you could use some kind of data science tools for those, and then kind of combine the two to understand the pattern between the history as well as the MRIs that you are getting or the diagnosis of the person. And again, it would involve a bit more domain expertise, because a, a medical professional who is actually dealing with this on a day-to-day basis, they will have more understanding of what or how the different patterns are correlated to the history, and that information that we as humans have already acquired, you could use that to improve your algorithms and make them even better.
Thank you, sir.
Okay, if there are no other questions, I can move on. Yeah, so how until now we have studied or we have seen the applications for computer vision and the use cases, as well as a bit of introduction about it. But what should be the first step that I as a student should take towards approaching computer vision or towards learning computer vision? So for that, I'll introduce 3 skill sets that every computer vision engineer should have. First of them is about your tech stack, the programming languages and the libraries or the frameworks that you should use. So there are 2 programming languages that I would recommend that everyone or every computer vision engineer should know about. One is Python and one is C++. Both of them have their individual roles. Python is for prototyping, for POC, for quick demos, for training your models, and for visualizing them and checking if they're actually working fine or not. But if you want to deploy it on a commercial use, for example, if you want to deploy a solution that's for example, if I want to make a solution that does super resolution on video conferencing, because if we are talking on Zoom, say, now to reduce bandwidth, Zoom would be compressing my video frame before it's sending it to their servers. But when it's displaying to you as the users, it would again want to increase the resolution of those frames and display it in a higher resolution. So that's a super resolution feature. And for that, the latency is very important because there should not be any delay between what I'm speaking and what you are getting as the output. And C++ is quite fast in that sense. And for any deployment that we do for computer vision, we usually use C++. So it's necessary to learn both the languages. And in terms of libraries and framework, OpenCV is necessary to interact with images, to manipulate the images, to draw on top of the images. We'll see some examples of using OpenCV. And TensorFlow or PyTorch Lightning, all these are frameworks that you use to build deep learning algorithms. So you use these algorithms not just for computer vision, but even for other tasks such as NLP related tasks. And you could choose just one of these, either TensorFlow or PyTorch Lightning. One of these should suffice. Yeah.
So a question from Vinay SR related to this is that with TensorFlow phasing out, is it viable to learn it?
Right. So you are actually right. People are moving slowly towards PyTorch and PyTorch Lightning, and that's because they are easier to understand and they're very intuitive. I myself follow PyTorch and PyTorch Lightning. So if you are starting to learn computer vision, I would suggest going for either PyTorch or PyTorch Lightning and not worry about TensorFlow too much right now. But I just listed down there because that was another alternative that people could use.
Okay, sir.
Okay. The next skill set that you need to have is mathematics and machine learning. That's actually important for building any deep learning algorithm because deep learning is just mathematics and machine learning applied to it. So it's really important that you know the maths and how the algorithm is functioning, because if there are any issues, you should be able to debug those or you should be able to fix those. And the different things that you should know about are linear algebra, calculus, statistics. Calculus is needed because these deep learning algorithms, they work on gradient descent and they work on backpropagation, which is just pure calculus. So you should be aware of all those stuff. And then machine learning and deep learning. So I believe you would have already studied about machine learning in data science course. Deep learning might be something new. Deep learning is actually deep neural networks where we have multiple layers called the hidden layers, and they kind of feed into each other to produce the output. So these are very complex models, and there are different flavors of such models. Simple models such as multi-layer perceptrons, they are also called feed-forward networks. They just take vector input and produce a single output or a vector output. Then there are CNNs, that's called convolutional neural networks, which actually operates on images. And then there are recurrent neural networks or RNNs and LSTMs, which operate on time series data. For example, share market data, where you are getting data every second or every minute. Now, I have listed a couple of links here just for your reference. Linear algebra, you could take this course from an MIT professor called Gilbert Strand. This is a really popular course. And after taking this course, your linear algebra fundamentals would be quite clear. So this is a really good course. And then for deep learning, I have listed a Coursera course. That's also a good one. And I really recommend to take that to understand about deep learning and how it works. Uh, small tip from my side would be that you should not skip this step because it's really important to have strong mathematical foundations to tackle the steep learning curve in learning computer vision. Because once you are starting to learn computer vision, you will have a challenging learning curve, and you might feel that mathematics and machine learning are the most challenging pieces of that, and there might be an urge to skip these. But to be a successful CV engineer, it's really important to learn all these. The third skill set is to actually know about different image processing and computer vision related algorithms, such as for different tasks, such as for classification, for image recognition, for object detection, and segmentation, or for generation. Generation is still in early stages and people are working on these, like GANs or the diffusion models or even NERFs are there these days. So it's still evolving, but the other fields are kind of saturated and you should know about uh, the basic, and you should at least have a basic understanding of the different algorithms that I've listed down here uh, to be able to build good computer vision algorithms. Now, different learning pathways that you could take. I'm sorry, probably this slide is not visible for me. Let me just quickly edit it. Yeah. The different learning pathways that you could take for starting with computer vision. I've listed a lot of resources there. And I think there was a question in the middle where the person wanted to have a few newsletters or blogs. You will find all that information here. Now, there are three things that I recommend doing to learn computer vision. One is educational resources, so such as courses or tutorials. There is a good website called Search, which has a lot of good blogs and tutorials, starting from the scratch of computer vision and going into details. So you could follow that. You could use that to understand about computer vision. Then different courses are available, such as on Udacity, edX, Coursera, and a few of them would be free as well. You could always study those to get more insights. And OpenCV also has a lot of courses which you could take. So there are abundant of resources, even on YouTube. If you just type learning OpenCV or learning computer vision from scratch, you would find a lot of information. Then there are engineering blogs by these big tech giants such as Nvidia, Google, OpenAI. So in these blogs, they release different products information and the different techniques that they use to build a product. So it's good to keep an update on, be updated about these blogs to understand how the industry is progressing, what the industry is actually using, and to know what's actually relevant. And if you want to go the traditional way, and then there are a few good books that you can read, such as this first one, Computer Vision Theory and Application by Zaleski. It's a really good book and it has a lot of insights. It's kind of considered as the Bible for computer vision. It references a lot of other papers as well, so it will provide you a lot of resources if you want to delve deeper into it, why a particular algorithm is working or how it's working. And if you want to learn about 3D computer vision or extracting 3D information from multiple images, then there is this book, Multiple View Geometry in Computer Vision. I think it's by Andrew Gisserman. And then if you just want to learn about deep learning, then there is this book by Ian Goodfellow. He was the author for GAN paper, which has really transformed the field of computer vision. And he has released this book on deep learning. That's also a really important and a good book. So this first step in this slide that I mentioned, it's about educational resources to gather information about computer vision. The next step is practical experience, because no matter how much theoretical information you have, unless you apply it practically, it won't be, you would firstly, you would not know whether you are learning the correct things, and you would not have the confidence to build something. So it's really important to have the practical experience. And Kaggle is a good place for that. Kaggle is a website that hosts regular competitions, and it has a lot of projects on machine learning and computer vision. I really recommend checking Kaggle out and doing a few projects on that to gather insights about how actually computer vision is working, or showcase your skills there. Next, if you are going for, say, hiring, or if you're looking for potential hiring opportunities, or you want to interview for a big tech roles in a big organization, then you should build a portfolio of good projects that showcase your skills to potential employers. Possibly you can have your website where you can list down the different projects and the links to those. And then I would recommend to use pre-trained models and build demos on top of those. I'll give you an example of a few such demos, but the idea is that building these models from scratch, such as YOLO. YOLO is actually a model for object detection. And these are very deep models. MediaPipe is from Google. It has a lot of different algorithms for face detection, for hand tracking, for body tracking, etc. Now, building such models from scratch, it requires to collect a lot of data. It requires to train for a lot of time. But if someone is starting from scratch, the first thing is to take these models as is and build on top of those, because that way you will save time in training and data collection, data cleanup, and all that stuff. But you can still be able to showcase some good demos by just using these models. And that way you will get some confidence as well that, okay, this thing is for me, I can do it. And then once you are ready and once you have that confidence, then you can start to train these models or fine tune these models. The last thing could be to contribute to open source GitHub projects around computer vision. So just search for important or beginner friendly computer vision projects on GitHub, which are open source, and you could start by contributing there. The last thing is, like I was mentioning earlier about the field and the continuous updates that are happening in the field, and the progress is actually very rapid. Every week or 2 weeks, there's a new paper that gathers a lot of attention, and then that looks like it will transform the field. And even before it does so, there's a new paper that comes out. So the field is really moving fast, and we should be up to date with the latest research. There are different resources for that, such as going through this 2-minute papers channel on YouTube. It releases, it shows, or it explains important papers in, or give a quick summary of the important papers about different fields of AI. And a few newsletters are Modeling Paper or Inside AI, which you could use to be up to date with the field. So there are a lot of content that's available online, and you can use that. I've listed down a few things that I identified in this slide. You could use this for reference, but there could be other things as well, and you could just search. A quick Google search would tell you what exactly, or it would give you some good important resources which you could use. So here's a breakdown of the different stages for onboarding to computer vision. First stage would be to get your fundamentals right in terms of programming. You should at least have intermediate stage of knowledge about Python and OpenCV. And I think a beginner level knowledge for PyTorch should be enough. Once you have that, you can take a course on ML or DL and linear algebra, and that will build your mathematics. And the last step would be to use these two learnings from stage 1 and stage 2 and apply it to practical projects on Kaggle or on GitHub, or even building on top of the already pre-trained models. So I'll be going over a few example projects. I think we are nearing time. Is it okay if we extend, or should I speed it up so that we can complete it quickly?
No, sir. Okay, it's okay. Fine.
Sir, feel free to extend it.
Yes,
Okay.
sir.
Sure. So a few example projects that I would like to give, just so it kind of intrigues you and it tells you how to proceed with this. First could be a real-time license plate detection, for example. So what you could do is, so the idea here is, for example, you could deploy, you could have a camera that's placed on the roads or on the highways to monitor the speed, or to monitor if the person is driving the car the wrong way, or he's violating any rules. And for that, you would want to issue automatic challanges. I think it's already done in Bangalore and other metropolitans. So for that, you would also want to detect the license plate of the number of the vehicle and identify the number associated with that. And what we will do here is, we'll use a YOLO V7 model, which is object detection model, and we will fine tune it for exact task that I just explained. Now for this, you take the YOLO V7 model and you gather some data set from online, which has the number plates and the associated bounding box on the car that tells where exactly the number plate is. Then you fine tune that model, YOLO model, with your small data set. Since it's a very small data set, it should not take too much time to train it. Once you have the fine tuned model, you could build your inference pipeline that detects the license plates, and then you can use the OCR. OCR is just optical character recognition, and you could use another pre-trained model to detect the license number on the plate once you have identified where exactly the license plate is. It has applications in traffic surveillance and monitoring. Another such application or another project could be about recognizing gestures using MediaPipe. For example, we could use MediaPipe hand tracking and hand landmark solution. So it basically detects the hands of the person, identifies the different joints on the person's hands. So for example, we could use the hand landmarks to build a gesture recognition engine. So say if I want to control the mouse on my laptop, now what I could do is I could place my finger in front of the camera and I could rotate my finger so that I can control the mouse around that. And this algorithm that you build, it's actually at every frame, it's detecting where my index finger tip is, and using that, it's feeding that information into the OS that's running on my PC, and through that, it's able to identify the gestures and control the mouse movements. You could also build on top of it to control the volume, for example. So for example, for volume, you could have a gesture that does this to increase or decrease the volume. And here you are tracking the two joints on the hand. But again, here you are not building any deep learning model from scratch, but just using pre-trained deep learned model from MediaPipe for hand tracking and building on top of it to solve a problem and build a good demo. So these were the two projects, just sample projects that I could think of. But you could do something similar where instead of training anything from scratch, you use the pre-trained models and use those to build on top of those. Before ending, I'll just give a quick overview of how images work and how different algorithms on top of images. You could use OpenCV on top of images, like a quick beginner-friendly session. So the basics of images are as follows. You have images that are actually pixels, but they're arranged in a grid-like fashion. For example, the image on the left is what we see as a human, but what your computer sees is something as on the right side, where it just sees a number. And these numbers can have range between 0 to 255. And whenever there is a bright pixel, such as the white pixels, you will notice that the range of the number is, the value of the number is higher. So when this B is formed, you would notice the brightest regions have the highest number, whereas the darkest regions will have low numbers, such as zeros on the top left. Since this was a grayscale image, it has just one channel. But if it was a colored image, then it will have three channels, or a depth dimension will be there, which will have three channels corresponding to red, green, and blue. Now, consider there is a RGB image of resolution 256 by 256. So it will have 256 into 256 into 3. 3 is for RGB. So this is around 200,000 values or 2 lakh values just to represent a single image of 256 by 256 resolution. So it's like a matrix that you have, and you feed that matrix to your computer or to your computer vision algorithm. Now, how can we use OpenCV to read images? A quick code overview. This is taken from the internet, but just wanted to give or get your hands dirty just by showing a quick example of how we can use OpenCV to read images. First, you import your regular stuff, such as importing the OpenCV library. Then this is the command that actually reading it. So image equal to cv2.im read. Then you specify the path of the image, and it will give you the image. And when you do image.shape, it will tell you the shape, which is height, width, and the depth of the image. In this case, the depth will be 3 because this is a colored image. And if you want to show what you have actually read, you could just do cv2.im show, which will display the image. And if you want to write it back to the disk, you could do cv2.im write. The wait key is just that the code will wait for you to press a key before closing this window that will pop up. Now you could use OpenCV to resize your image also. You loaded that image, but it was a high resolution image and you want to say downsize it to 200 by 200 pixels. You could just use cv2.resize image, 200 by 200, and it will show an image, or it will resize it as shown here after resizing. So you see the depth, the height and width of the image have reduced. If you want to draw on top of images, what you could do is, there is a cv2.rectangle command, which specify the top left and bottom right corner of the rectangle that you want to draw, the color. So 00255 means the red color, and the thickness of the boundary of the rectangle. You could just specify these information and it will draw on top of an existing image. These are just a few example code walkthrough in PyTorch, like how you would build a neural network and how you would load the data. I can go over that, but before that, if there are any other questions, I would like to answer that.
So there is one question from Orkodas. He says,
Yeah.
in my current approach to video analysis, I divide videos into individual frames and process each frame as an independent image. However, I'm interested in capturing and processing the temporal information across frames. How can I use temporal information into my video analysis, and what techniques are best suited for this purpose?
So if you want to capture temporal information, then either you could go for algorithms, deep learning algorithms that are built for capturing that information, such as LSTMs or attention-based networks, which actually capture the different time domain information. The input to these networks is the video itself, frame by frame, but they operate on each frame individually, but they still carry some information from the previous frame. So that information that can, the time information that can be passed on from one frame to the other. And other way could also be that you could manually decode that time domain information in a video through, say, optical flow networks. In optical flow, you capture how each pixel is changing across different frames in a video. And you could use that optical flow information to pass into your network.
Thank you, sir. Orko, I hope your question is answered. Sir, you can carry on.
Sure. Okay, let me see. Hold on. I just wanted to quickly show how you use PyTorch to build deep learning algorithms. Now, in PyTorch, this is from PyTorch website only, and this will also tell you that you could just go on PyTorch website and search for its tutorials to start with and to start learning with PyTorch. It has good amount of documents and tutorials that you could use to get started on PyTorch. Now, say if you want to train a deep learning model for some computer vision task, and we want a particular data set for that, we would want to load that data set and then reuse it. Now, PyTorch also provides a lot of data sets that you could just use directly. No need to gather the data set from the web and clean those. It already has done that for you. For example, there is a fashion and NIST data set. It has around 60,000 training images and 10,000 test images. And each image is just 28 by 28 grayscale image. And it has 10 classes associated with each. So each image will be labeled in one of those 10 classes. So if we want to use this data set to build our model, what we will do is we will import the usual stuff such as Torch utils data. And then from Torch Vision, we'll import the data. And in this data sets, we'll specify, In this data set, we'll specify that we want to use fashion MNIST data. We want to tell where to download the data set. That will be in our data folder from the current directory. And we'll specify that we want to load the train split of that. That is the 60,000 samples that we just saw. Download equal to true means that it will download it to your local disk. And then you usually apply a transform to your data. Transform basically takes an input image and applies some operations on top of that input image. Here, they're just converting it to tensor. So tensor is PyTorch representation, and PyTorch uses tensors to apply and operate or compute the deep learning models' outputs and inputs. So they're just using tensor here, but you could use other operations such as resizing or normalizing, cropping, and other stuff as well. And similarly, they're using a test data from MNIST, but here, if we notice, they just specify train equals false. That means load the test data. And here it's loading the data. Once the data is loaded, what we can do is we can visualize what we have just loaded. So for example, we could run a loop that iterates over the training data that we just loaded. And yeah, it generates an image and the corresponding label. And once we visualize that, we'll get something like this. So there will be first image of a boot, for example, and the label for that would be ankle boot. Then there will be a shirt and so on. So when you iterate over training data, you will know what kind of images it has, what kind of labels it has, and you can visualize that. So this is one data set and the way to use PyTorch inbuilt data set, because it will save you a lot of time in gathering your own data sets. The next tutorial that I wanted to cover was how to build a neural network in PyTorch exactly. I won't go into the details of how neural networks work and how they function, but just a quick overview of how you could use PyTorch to build and train neural networks. So once you've imported the regular stuff such as the torch library, the data loader, and then the data sets, we'll first check if we have a GPU enabled device or just a CPU. And for that, there is a command in PyTorch called torch.cuda.is available. If that's true, we will set the device to CUDA, else we will set it to MPS or CPU, whatever. And here we are defining the neural network architecture. So we have three layers here, three linear layers. So first is 28 by 28 because our fashion MNIST images were 28 by 28. It takes those images and it takes those to a dimension of 512. It applies a ReLU activation. Then again a linear layer from 512 to 512 dimension. Again a linear layer, a ReLU layer, and then a linear layer that gives you 10 values at the output. Why 10? Because your fashion MNIST dataset, it had just 10 classes. And then you build the forward function. The forward function is actually where your forward prop or the forward parts of the neural network happens. It gets the input and it operates on those inputs, whatever you have defined in the init function of your class. So this way we have defined the neural network architecture. We take this neural network architecture and we take it to the GPU, and then that takes our model to the GPU, and then we can just use trainer from PyTorch to possibly train the neural network. So let me see if they mentioned that here. Yeah. So once you have defined your model, what you could do is okay, they don't mention the trainer here, but you could just say model.train and you could start training the model in PyTorch. So that's what I wanted to cover actually. If there is any other question, I would like you to ask those and I can answer those quickly.
Sir, I have one question.
Yeah.
It's my personal. I was working on a project of detecting the sign language and converting it into the text. And I was using TensorFlow Objection Detection API, Python, OpenCV, and Label IMG for the image annotation.
Okay.
So my issue is you also said that we can use YOLO, but I was thinking of using faster RCNN or SSD, which will be better for my project.
I think you'll have to try it out. It's really difficult to say exactly which will be better. Uh, but from just my intuition, I believe that SSD could be better than faster RCNN.
Okay,
But
sir.
again, you need to try it out to give it a shot.
And one more thing, sir, is there any pre-trained model about the sign language? Because right now I am capturing my images and then labeling it manually. If the data set is already available, then it would be very helpful.
You want a pre-trained model for sign language detection, is it?
Yes.
Check on Kaggle, you will find something.
Okay.
I remember seeing it. It was there.
Okay, sir.
Yeah. Yes, Manohar, you have raised your hand.
And we have some questions in the chat box also, sir. If
Yeah.
Sir,
yeah.
I would like to ask that let's say I want to make a project using OpenCV, sir. So, what would you suggest? Like, use a pre-trained model and enhance it, or make a deep learning model from scratch, sir? What would you suggest?
What exactly do you want to do? Can you repeat your objective?
Sir, like, I want to make an OpenCV project, anything using OpenCV, sir, and I find some pre-trained model perfectly fit
So
towards
you
it.
should use the pre-trained models to start with. Build the complete
Uh,
pipeline, see how exactly it's working. If you find that your pre-trained model is not working well for your application, then fine-tune it or train a model on your own.
okay, sir.
The rule of thumb is that reuse whatever you can. Don't reinvent the wheel. Just use whatever is existingly available. And if it does not suffice, then start to build on top.
Hi,
Yes.
I'm Vinay. I have one question. I prototyped a small application wherein we can, use image overlays over a CAD file. So I just wanted to know, like, how can we, extend these things to, automate it? So this is mainly predominantly, it is with respect to a manufacturing application concerning quality. So a quality inspector, checks whether the CAD model and the image captured has, the right set of features. So right now it
Mhm.
is kind of being done manually.
Hmm.
So my ask is like, how do we connect this one with the CAD model?
You could build a model that takes the CAD file uh, as input, or possibly you could extract the point cloud from the CAD file. There could be different ways you could feed the CAD file as input to the model. Once you know that, then you could build a model that takes that CAD file as input and takes the image as input, and then kind of compares the two and give you an output. But for this also, you will need uh, annotations and annotated data. And for that, again, you will have to collect that data manually through manual annotators.
Okay.
Amazon Mechanical Turk is one website that helps you gather annotations or collect annotated data. So you could try to use that as well, but it involves a cost to it, so that depends on the budget.
Yeah, thank you.
Okay. Can someone go over the questions in the chat if there are any thing that,
Yes, sir.
yeah.
The first question is asked. Is my voice audible?
Yes, you can. You are able
First
to.
question
I mean,
is asked by Arvinder Singh. What is your take on transformer architecture in the computer vision field, and what do you think how they are better than CNN?
computer vision field for trans. Okay. Um, so the transformer architecture was introduced in this paper called "Attention is All You Need," and I think it has really transformed the field quite a bit, I would say, uh, because uh, before that, people were just relying on LSTMs and RNNs for video processing, but now this transformer architecture has introduced attention concept, and that has really helped capture longer context, uh, in the models, and people are turning to these attention models for all the tasks. So that's really helpful, and I believe that that's kind of important for CNN models too.
And last question, sir, is asked by Vinay. Is there any path for comparing CAD model spaces with images with respect to manufacturing applications?
Yeah, I think I just answered that question from
Okay,
Vinay, right?
no worries.
Yeah.
I think Nishant has raised his hand. You can unmute Nishant.
Yes, sir. Sir, so my question is, in your explanation, you told about generative models like GANs and diffusion models. So, what is your opinion on using these in CV projects? Like one thing I could think of was data augmentation. And so, if I had to create a project like using these newer technologies, then what would be your advice, sir?
Um, you could use either of these. Just two things to be clear about, or you should know before proceeding with using one of these in your projects, is that GANs, they are usually harder to train. You might get stuck in a problem where your model is not training, or it's not giving correct outputs. And diffusion models, they are really slow right now. Their inference process is really slow. So it's people are working on speeding them up, and possibly in a year or two from now, we'll have diffusion models that can run in real time. But right now, for real time applications, they are slow. So considering these points, you should think about using either of those in your applications. But yeah, these are generative models, so you could use them to collect more data, or generate synthetic data, or augment your data. Yeah, Shashank?
Yeah, hi sir, good evening.
Yes, good.
Actually, I'm working in manufacturing industry and we use vision system to for checking the object detection model using yellow.
Mm-hmm.
So for in manufacturing industry, the challenge is every time new models came. So every time we have to annotate the model. So that took us so much time. So is there any process so we can avoid less manual annotation process because we have to take 1,000, 2,000 images for doing that.
Right. Uh, there are different ways that you could try, such as generating synthetic data for that task, um, in the sense that you would not rely on manual annotations, but you would use some tools to generate uh, different images. For example, if you want to detect, say, a fan on a ceiling, now one way is to capture those images using a mobile phone and capture 1,000 or 2,000 of such images. But other way could also be to generate such images through a toolbox. For example, you could have a single CAD file, and then you could just render it in different views from a different viewpoints, from in different colors against different backgrounds. So you could write a script that takes that CAD file as inputs and generates, say, 50 or 60 image files out of those. And then you could have, say, 20 or 30 of those files, and you could generate different cameras, different fans in different lighting conditions and different uh, camera views. So that will save you a lot of time in annotations.
Okay, okay. Thank you very much.
Yeah.
Sir, a last question that we have is Nvidia has its own line of embedded CV applications. Right now, Edge AI is being used everywhere. How are the computer vision models being created for these devices?
So for these devices, we usually have models that are very small or very compact, and we try to optimize it for such devices in the sense that we would try to do pruning, or we would do quantization. That is, it would not operate on floating points, but it would just operate on integers. So that way, the speed up that we get is significant. And then we try to reduce the size of the model as well, so that we are able to run it in real time on these edge devices.
Okay,
Is
so
there
I
any
think
other
it's
question? Yeah.
late. So we should wrap up the session now. Thank you so much, sir, for this insightful presentation and answering all these questions. You have made this very interactive. Thank you to all the participants as well. You all have also asked so good questions that you made the session interactive. I hope that everyone found this session valuable and you have gained a deeper understanding of the roadmaps to becoming a computer vision engineer. If you have any further queries or any additional information that you want to ask, sir, I believe you can feel free to reach out to sir. Thank
Yeah.
you again for joining. Have a great evening and thank you so much, sir.
Sure, no problem. All the best to everyone who attended this session. Good luck for your journey in computer vision. Thanks a lot.
Thank you, sir.
Thank you, sir.
Thank you, sir.